Hey guys, sorry this video is getting to you a little later than it should. I had some stuff that came up that needed dealing with. This video, we've primarily been through, or pretty much been through everything that you need to know theory-wise. I'm just going to explain things in a little bit more detail and give you some examples of some stuff to help you get ready for your test. So let's get started on this. So first things first, as I talked to all of you guys at the end of the last lab class for all three groups, I had shown you guys a YouTube manometer and the YouTube manometer had measurements up and down. And we had talked about having multiple ports on the manometer that were very important to know which one had the supply connected to determine whether it was a positive pressure or negative pressure. So we are going to look at two ports off the top. We've got port number 1 and port number 2. So port 1 and port 2. As we had talked about, when there's no pressure applied, the fluid is resting at 0, and let's make this in a different color. So just imagine the red is the fluid that's inside, and we are going to apply pressure to port number 1, and we end up getting 1.5 on one side and 1.5 on the other side. So from what we had talked about, if I just color some of that in just so you can see it a little better. So we've got fluid at 1.5 on one side, 1.5 on the other, and we had talked that you take the sum of the two values. So 1.5 inches water column on one side and 1.5 inches of water column on the other to give you a combined 3 inches of water column. So nothing too crazy. So we had said that the applied pressure was at port number 1, but if we looked at this as well, and let's say that the pressure instead was at port number 2. If the pressure was at port number 2 and we had the exact same measurement appear on here, we still would see that there's a difference of 3 inches of water column. But if the pressure was applied here and we had the fluid being pulled up towards port 1, let me just start playing a little bit there, starting to lose the camera. If we did that, we would end up seeing that actually if it was being sucked back up to port 1, that it would be a vacuum. A vacuum towards port number 2. And as we had talked about the other day, a vacuum is from from sea level. And the vacuum is based on 0 psig, not psi. So we have an amount of 3 inches of water column in a vacuum, and we can have many different pressures in a vacuum. It doesn't have to be psi like we had said. We could also have had inches of mercury, we could have had kPa or bars. Okay, so fairly straightforward. Now I want to look at a question that I want to try and get as much of this together as we can. So I'm going to write a word problem because a lot of the questions on the test are going to be word problems. feet. Okay, so a column of mercury 24 feet high is being looked at. What is the pressure in PSIA? So with this question, we've got multiple things. We know how high the column is 24 feet high. But I want you guys to figure out what the overall pressure is in PSIA. So if you want to pause the video right now and work through it, that's fine. Or if you want to just watch and I'll go through this one with you. So we have a column of water that is 24 inches or 24 feet high. So the column is, and hopefully my marker doesn't die, 24 feet high. And obviously when we're looking at mercury as a measurement, we want to get it in inches. So I take my, use my red here, maybe a green too. Let's see. Let's see if the red works. So we got 24 feet times 2.0, actually, times 12, 12 inches, and that'll tell us the total number of inches that we are using. So I believe it should be 288. So we got 288 inches, so that would be inches of mercury, okay? And then now we want to figure out what that measurement is in PSI. So the formula that I had shown you guys is, so 1 PSI, and when we do this conversion, remember that it's technically in PSIG. So we have 1 PSI over 2.04 inches of mercury, and that's equal to 288 inches of mercury over an unknown PSI. So we cross multiply first, so 1 times 288. As we know, 1 times 288 is 288, and then we divide by the other unknown value, so 288 divided by 2.04 gives us an answer of 141.18 PSI. So that's what the amount is in PSIG. And then we want to know then what that answer is in PSIA. And remember, when we're looking at PSIA, we need to add 14.7 PSI to our value. So it's 141.18 plus 14.7. And that gives us a value of around 155.8. That's the two decimals, 88. Okay, so that's how that problem would be solved. So throughout the entire test that you're going to be doing, you're going to have a bunch of questions like this to go over and try to be as familiar as you can with the values. I'm just going to list a few more conversions here on the board for you, and then I'll go through them so you can work on them, and then or pause the video, work on them, and then I can go through them, or you can, as I said, just watch through. So we have, let's do 18 psi, so that would be in PSIG, 18 psi to inches of water column. We have 96 kPa to inches of water column. Let's do 109 inches of mercury to bar, and then 1 bar to inches of mercury. So pause that, work through it, and I'm going to start going through all these values. I'm just going to write them off to the side and then take this off the board. Okay, so we have 18 psi, 2 inches of water column. 18 psi we know is equal to, so we have, 1 psi is equal to 27.7 inches of water column, and we have a unknown water column that is equal to 18 psi. So we have an unknown water column. So we multiply together what we know. So 27.7 times 18. 18 times 27.7. We get an answer of, so 27.7 times 18 is equal to 498.6, and then we divide that by 1, which is obviously 498.6 inches of water column. And so that's your answer for the first one, 498.6 inches of water. All right, next one. Next one we have 96 kPa, 2 inches of water column. And we can do the direct crossover to it. So we have 6.895 kPa over 27.7 inches of water column is equal to is equal to an unknown water column, and we have, no, that was already, sorry about that, 27.7, just brain farted there. We have an unknown water column, and we have 96 kPa. All right, so we multiply across what we know, so 27.7 27.7 times. So we get from that 2,659.2. And then, so that would be, you could do WC slash KPA, and then I divide that by 6.895 KPA. And we get an answer of 385.67 inches of water column at the end of that. Next question. Next we have 109 inches of mercury to bar, 109 inches of mercury over a unknown bar, and we have 2.04 inches of mercury and 0.0689. So we multiply across what we know. 109 times 0.0689 gives us an answer. So we get 7.51 and divide that by 2.04, and we get an answer of 3.68 inches of 3.89 bar at the end of it. Right? Last one. Now we have 1 bar, and we're going to turn that into inches of mercury. So 1 bar over an unknown inches of mercury is equal to 0.0689 divided by 2.04 inches. So we do 1 times 2.04, which is obviously 2.04, and then we multiply and then divide by the only other one, 0.0689. So 2.04 divided by 0.0689 gives us an answer of 29.61 inches of mercury. Okay, that should be everything there. Hopefully that went well for you. So I'm just going to pull away from this a little bit. I'm just going to go over the atmospheric pressure stuff a little bit, and then I'm going to talk about ladder diagrams and push buttons and stuff, and then we will end this video off. So in remembering from the last class that we had in the lab class, we had sea level, and at sea level there was 14.7 psia, which was also equivalent to 0 psi G, which is at that point 0 psi vacuum. So at this point, remember, at the atmosphere around us, it ends up putting 14.7 psi onto us. So if we go up into space, there would be a absence of atmosphere. So essentially we'd be in a vacuum. So it's a lack of atmosphere, there's a complete vacuum. So at 0 psi A, that is a complete vacuum, and a complete vacuum is negative 14, or sorry, is 14.7 psi vacuum. And then if we look the other way, and we went up, if you recall, let's say this was 37 psi. At 37 psi, here, that would also be 51.7 psi A, as this is G, so I added 14.7 onto that. And if we were looking at a vacuum amount, that would be negative 37 psi as a vacuum. So try not to confuse those values on the test. Remember that sea level is your baseline. When you go down, you know, a complete vacuum is 14.7 psi. So keep that value in mind, the 14.7, for going back and forth between complete vacuum and your PSIA. Okay? Something else to remember for the test, remember there is 2-wire control, and we also have 3-wire control. So 2-wire control, as we talked about, was essentially just having a toggle switch going to a pilot light, and once the switch is closed, completes the path, light turns on, so obviously you have a source and then return. So that was 2-wire control, and 3-wire control had a stop, had a start with a holding contact, and a pilot light. So know the terms of a holding contact, which latches the circuit. Know the symbols, know that that's a pilot light. Know that that's a normally open push button, that that's a normally closed push button. And so this would be a start, so it'd start your circuit. The stop would stop your circuit. Know that if when you're having an ohm meter, how would they appear if you were to ohm them out? So if I were to look at a toggle switch, my toggle switch is open right now. When the toggle switch is open, and I would put a meter across, I'm just trying to line that up without looking at it. If I put a meter across there, I would end up seeing a resistance right now of OL. When I go to close that switch, and I went to put a meter across those 2 points, it would read 0. So closed switch measures 0 ohms, and open switch reads OL. Likewise with a normally open momentary push button, it would appear the same. So when you don't push the button, it reads OL, or infinite resistance, and when I push it down, I would read 0 ohms. The normally closed, so that was the normally open rate, and the normally closed is going to read as 0 ohms when you haven't pushed it down, and when you push it down, it would open up and read infinite ohms, or OL again. Your holding contacts, which are a dry set of contacts, and remember, a dry set of contacts means that it does not produce its own voltage. It needs to be supplied voltage from something else, so we've supplied it with power from our power supply, but it doesn't produce its own voltage. Actually, that wasn't a pilot light. I don't know why I did that. That was supposed to be a coil, not a pilot light. And that coil, typically coils are labeled as A1 and A2, and remember in lab they were terminals 13 and 14. So be mindful of all those. Kind of think I might have a couple questions on the test for how it would function. So there might be something wrong with the circuit, or I might say, hey, how does this circuit work? So know what everything's going to do with the circuit. Look over all the diagrams that you've drawn for me in class, and you shouldn't have an issue with the test. Pilot lights can be, amber, green, or red, any combination of those. Make note about loads on the same rungs. Don't have two loads on the same rung. They need to be in parallel, so on two completely separate rungs. So this was 3-wire control, that was 2-wire control. And then just what I want to say with tests as you're going through them. Try not to overthink the questions on the test. They are fairly straightforward. I'm not going to try to trick you at all. And also too, with writing tests, typically your first answer that you go to pick is typically the right answer. If you start second guessing yourself, typically you'll end up picking the wrong answer in those cases. So I think, and as well with this, being at home, you got time. I'm going to give you a couple hours to write the test. So you shouldn't have any issues getting it done with respect to time. One other thing that might be on there, there might be something with a fuse on there. I don't know if it's on this one, or you'll find it maybe on one of your other tests that come up. So this is your fuse. When you're ohming out a fuse, if a fuse is good, a good fuse is going to read 0 ohms. Okay, a good fuse reads 0 ohms. A bad fuse, when you go to test it on your meter, is going to give you the infinite symbol, or OL. So infinite resistance. So something else to keep in mind. As long as you know how to do the conversions and you know all that stuff and the ladder diagram stuff, you should be okay. There will be a few questions now, which I'm going to get into on pressures equal force over area. So I'm going to do a couple of those examples with you. I'm going to write them out, have you solve them, and I don't think you're going to have an issue with the test if you can do everything that I'm showing you right now. So, all right, so next, let's do Alright, so this is kind of crude. Johnny sits on a tack. The head of the tack is 0.01 square inches. If Johnny weighs 100 pounds, how much force does the tack pierce with? So I'm going to take the important information out from here. So I have 0.01 inches squared, and I have 100 pounds. Poor Johnny. So pressure is equal to force over area. The pressure is equal to my force, which is 100 pounds, over 0.01 inches squared. And it should actually move the decimal place 2 over. So I think it should make it out to be 10,000. 100 divided by 0.01. Yeah, so 10,000 pounds per square inch on Johnny's bottom when he goes to sit on the tack. So that would definitely not feel well at all. Alright, I'm just going to do one more here. Let's see. So a pillar is standing straight up. Its base is 2 feet by 2 feet, and it is 15 feet high. It weighs 2,000 pounds. What pressure does it apply to the ground straight up and on its side? Okay, so a pillar is standing straight up. Its base is 2 feet by 2 feet, and it is 15 feet high. It weighs 2,000 pounds. What pressure does it apply to the ground straight up and on its side? So I'm going to look at it when it's in a pillar this way and when it's leaning over. So the important information for our pillar: it's 15 feet high and it's 2 feet by 2 feet. And we've got 2,000 pounds. So firstly, P is equal to F over A, and we're going to be looking at it in this configuration here, so 2 feet by 2 feet, 2,000 pounds, and 2 feet by 2 feet is actually, you got to make the distinction, 24 inches by 24 inches, right? Because we've got 2 feet, we need to do this in inches. not in feet. So we have 24 times 24 is 576. 2,000 divided by 576. And we get a pressure of 3.47 psi. Okay, so that's the one way, 3.47 psi. Now we're going to look in the other direction. So the weight, as we know, stays the same. But now it's fallen over, so it's going to be this side here. So it's 2 feet by 15 feet. So 2 feet, as we said, was 24 inches. And 15 feet in inches, 15 times 12 is 180. So that equals to 2,000 pounds divided by 180 times 24 is 4,320. And be sure on a test that you recognize if something's in feet, and if something's in feet and has to convert it to inches when you go to do it. So your answers aren't out of whack. Divided by 4,320, and we get 0.46 psi. All right, that is everything, and I wish you guys luck on the test. And I'll be putting the pre-test up for marks. That's also going to help you prepare for the test. Okay, have a good day.